We're going to give a little bit more time for people to join. So let's start in about 2 minutes. And I do know that this is actually going live on LinkedIn and YouTube as well. So if you're joining us from LinkedIn and YouTube, quick introduction. My name is Ashwin Ramachandran. I'm the head of engineering at Interview Kickstart. And I'm going to be your host for the session today. So let's give it another 2 minutes. Awesome. I see a lot of people joining. All right, while we are waiting, we want to kick off a little poll. I just want to get a sense of where all of you are at in terms of your understanding of generative AI or just keeping up with what's going on. We'll kick off a little poll at this point, and just select your option. I'd love to know where all of you are at. Nice. I can see all of you respond to the poll. I can see some of you have actually built a small app. That's very cool. Most of you are following the news. Obviously, many of you have actually played with ChatGPT. Very interesting. So a lot of you played with ChatGPT, which is great. Which tells me that you're obviously interested. You sort of dug in there, played around with it a little bit. A lot of you are following the news. It's very hard to escape the news. And a small percentage of you have built an app. So that's very, very interesting there. Excellent. It is 8:03 PST, I think, or 8:04 PST now. Great time to start. Let me go ahead and share my screen. Awesome. Upsides episode 8. Welcome to part 2. So we did part 1 last week. This is part 2, the generative AI toolkit. And today we are going to do a little bit of a dive into the semantic kernel abstraction library. And we'll get to that in a bit. But let me tell you a little bit more about myself. I introduced myself last week. I see a lot of people are coming here for the first time. This is the first session you're attending. So what does my resume not tell you? And this is my favorite interview question, by the way. What does your resume not tell me? So, well, I believe my career essentially started when I was at Yahoo. I mean, I worked before that, but Yahoo was essentially my big break. Worked in NLP algorithms, natural language processing algorithms, before it was even a thing, before even NLP was a thing. One of the first pieces of code I wrote there was to see if Shaquille O'Neal talking about Shaquille O'Neal on some news article versus some Yahoo Answers thread, which is talking about the Shackmaster, is essentially the same thing, and then did it at scale, threw it at Hadoop, ran it across 4 billion pieces of content, caused all kinds of havoc. But was a lot of fun. But that was sort of my first exposure to machine learning, or what is it wasn't really called machine learning then, but that was my first exposure to that whole space. Took that experience, went to this logistics tech startup called Yacket. That's when I got deep into it. We did supervised learning for duties and taxes. Spent a lot of nights with very limited help, I must add, to drive prediction accuracy up to 72%, which is really, really good. Did the earliest version of MLOps, and at our peak, we ran predictions for over 2 million unique products a day. So this is quite exciting. Learning a completely new thing and driving it at production level scale, right? So that is sort of my exposure to machine learning and getting deep into it, which brings me to what I do today, which is interview Kickstart. I head the engineering team here. I built and I continue to build a powerful platform for cohort-based learning. So if many of you are students here, you've used UpLevel, so that was my team. And now, since the start of this year, I've gone deep into generative AI, building chatbots, support enhancements, teaching assistants, and sort of deploying LLM-powered apps across the business stack. But the most fun part of my job is what I'm doing now, which is sharing my experiences with the world. So that's me. Quick recap of the agenda today. So this is a 3-part series. So we did part 1 last week, where we did the lay of the land, kind of introduced you to sort of all the tools and libraries that are out there for building generative AI apps. Today, we are going to focus on one particular library, which is a semantic kernel, and we're going to write some code. So that is always exciting. So that is part 2 today, and part 3 is coming up next week, where we'll put it all together and build an app with all those tools and libraries. Now, it's worth revisiting a few things that we covered last week, and many of you are logging in for your first session here. You missed last week's session. I had introduced this sort of simple app diagram, saying that this is what the generative AI, a generative AI app architecture typically would look like, right? So you have your app, you have some input processing. That takes stuff from your front end, processes it, and then it throws it to this abstraction library, which then connects to a bunch of databases that you might have. You might have your vector DBs, relational databases, NoSQL databases, all of those. And then that abstraction library then connects to your model zoo, right? And when I say model zoo, my hypothesis is that you're not going to be using just one LLM, because your apps are going to be multimodal. They'll have different use cases. So you could be using a language model, you could be using an image model, you could be using a video model. So all of those sort of become part of your model zoo, and your abstraction library sort of connects to those. And then finally, a logging and telemetry, very important part, slightly boring part, but very important part of your stack, which is making sure that you know what prompts are going in, what are response times, and if there are any errors in the process. All of those become part of your logging and telemetry. But your abstraction library essentially does all of the heavy lifting there, right? And that's why abstraction libraries came up. We are talking about semantic kernel today. There is LangChain and there is Llama Index. But if this wasn't there, if there was no abstraction library, and that's the reason why we are talking about it today, you would have to build your own custom library, right? Imagine writing all of that code and which we already do to an extent today, which is to connect to all of our DB stacks, right? And doing all that error handling and management and doing all the CRUD operations, then implementing APIs for each of these models, right? So you have to implement those APIs, make sure that you're passing in all of the information to them, getting the response back, and then implementing your logging and telemetry, right? So just a lot of code that goes into orchestrating this entire layer. And that's why abstraction libraries are important, and that's why there's a lot of work going into building abstraction libraries there. Another thing worth revisiting is what a good abstraction library gives you, right? And I introduced this slide again last week, so worth revisiting because we're going to dive in a little bit deep here. You have your connectors to different models. You have different tools it gives you. different examples that you can use to quickly get your app running. You have prompts, your ability to craft and send prompts to your models, implementation with different vector stores, document loaders, output parsers. So things that you get back from the LLM, how to parse it and display it. And then your text splitters, and we're going to get into a lot of these in our session today. But this is typically what a great abstraction library actually gives you, and it's important to sort of keep this diagram in mind when you're thinking about this abstraction library there. All right, so let's get started. So some of these jokes here, if you like it, I came up with it myself. If you didn't, it came from ChatGPT. So let's dive into the semantic kernel. So before we sort of get into the coding part of it, let me give you a little history lesson, right? So what is a semantic kernel? How did it come about? There was this little company called Microsoft that decided that, hey, we are very interested in AI. And there's this little company called OpenAI, which we are going to put a ton of money in, and we're going to use all that goodness that OpenAI generates, right, with ChatGPT, and drive our Copilot stack, right? So Copilots is this whole stack of AI plugins and agents that's going to drive a lot of the Microsoft apps, everything from Bing searches to Office 365, all of those it's actually going to drive, right? So it's good. They want to embed AI into every single piece of their product. But as they were building the Copilots, they realized, man, this is getting really complex, right? So we have all of these native functions, right? All of this code that we've already written to drive a lot of our functionality in these products. And there is this new concept of semantic functions, which is fundamentally prompts, right? So we send these prompts to the language models and we get this data back. And then Microsoft has its own graph API, which then connects to all of their products and pulls in information from different products and merges them together. And then we have to orchestrate all of these things together. And in the middle of that, we have to maintain state for all of these. And that is what this memory is. And we have to keep injecting context, right? So we have to take data from the native function, put it into the semantic function, and then put it into the graph API. So there is all of that context going in there. It's getting very, very complex. And the goal going into this for them was, we want to make this accessible to all developers, right? So we don't want to make this like a Microsoft only product, just like the .NET stack. We want to make this accessible to all developers. We want to improve this Copilot stack in a way where people can contribute to it. There can be new plugins, there can be new native functions. So how do we go about doing that, right? I mean, this can get very complex. So they came up with this orchestration, right? So they separated out this layer, which is the bottom layer, which is all the foundation models and all of your infrastructures. They separated that out from the top of the stack, right? Which is all of the apps, all of your copilots, all of your plugins, and built this orchestration layer in the middle, right? So what is this orchestration layer? It completely separates stuff at the bottom here, which is typically where ML engineers and AI engineers live, data scientists live here, to the app development stack, right? Which is on the top, which is all building all the copilots, which is building all the plugins and all the extensibility built into that. So they explicitly separated these two things and enabled developers to live on the stack that they wish to, right? So otherwise, it was, if this orchestration layer didn't exist, people had to go back and forth between these two layers, and it gets very confusing, right? So they created a clear separation, and this clear separation, this AI orchestration, is what they call the semantic kernel, right? And a kernel from the Unix world is something that's just like an orchestrator. It's empty when you start off with, and then you add more things into it, processes and memory and threading and all of that. And in this case, they imagined it as, they called it the semantic kernel because in a semantic world, the kernel is essentially adding LLMs and it is adding vector databases and other things that you can plug into it and run your apps, right? So that essentially is the semantic kernel. All right, so now that we have the theory, let's go and code up a little bit, right? So I'm going to jump out of this presentation and quickly open up VS Code. Now, you can do this pretty much in any coding editor you want to. Semantic kernel is open source. It supports Python, it supports C#, it supports Java. My day job needs me to be a Python developer, so I'm actually going to use Python. But if you're a C# developer, if you're a Java developer, you can obviously use it there. So the other reason I chose VS Code is because semantic kernel comes installed as an extension to VS Code. So if you go into extensions, just search for semantic kernel, the semantic kernel tools pops up, and you can just go ahead and install it. And it gives you a lot of very interesting things, right? It immediately recognizes a lot of the prompts that you've written in your code, and we'll get to that part when we write code. It allows you to test those prompts, right? So it actually allows you to unit test some of those prompts. You can hook up OpenAI. I mean, today you can hook up OpenAI as an LLM. You can connect to Hugging Face models. So all of that amazing set of models that are available on Hugging Face. And obviously you can connect to Azure, right? So you can connect to the OpenAI instance installed on Azure or deployed on Azure. But what is also interesting, it gives you out of the box access to all the latest. So in this case, since I have connected to OpenAI, it gives you out of the box access to all of these OpenAI models, right? So you can see all of these over here. So it's just a matter of using which model. So especially when you're testing some of these prompts, and I'm going to not get into each one of these because I want you all to go back and try it yourself. So you can use these prompts, for example, and choose which model you want to test it with, and just go ahead and test it, right? So very, very cool a tool that just speeds up the application development process, right? The Gen AI application process. But let's start writing code, right? So I have this SK example. So the first step is to obviously import, and this is all Python. So if you know Python, you'll recognize this code. If not, I'll just explain as I keep typing. So the first thing to do is to instantiate a kernel, right? So that is the first step, and this creates an empty kernel, right? So just empty, nothing inside there, nothing fancy going on there. We just created an empty space. Now that the kernel is there, let's attach an LLM to it, right? So let's attach a language model to it. So I'll get all of my credentials. So I'm going to get my API key. I'm going to get org ID. So if you go to OpenAI, you sign up for their API, you get an API key, and then you sort of connect it with your OpenAI instance, and then essentially connect it to your kernel. So I'm going to get this. So this gets my OpenAI key and my org ID. So this is important for connecting to a GPT instance, right? So say API key, org ID. I have this little .env file here where I've put in my secret API key, which you need to put in there in your org ID, and this basically pulls it from there, right? So now that you have all of those credentials, let's go ahead and attach the LLM, right? So before that, I'm going to import semantic kernel dot connectors.ai .openai, and from here, I'm going to say from import, and I'm going to. So you have three options here. You have the OpenAI chat completion, the OpenAI text completion, OpenAI text embedding. We're going to look at the OpenAI chat completion today, and you can play around with the rest of it as you sort of get into the semantic kernel. So I'm going to go ahead at text completion service. I'm going to give it some names. I'm just going to call it ChatGPT because that's what we're going to be using as a language model. And here, I'm going to go ahead and instantiate this. Now, which model are we using, right? You remember when we went to the extensions, here we had all of these different models, right? So GPT-4 all the way down to the earliest ones, which is Curie, Babbage, Ada. I am actually going to go ahead and use GPT 3.5. It's just faster, and when we are doing demos, it's always easier to get that output quickly, right? So, and I'm not going to attempt to type it out. I have this trusty little file where I've copied a lot of these things so that I don't make a mistake. I'm going to do that and put in my API key and put in my org ID, and we are good to go, right? So now we have attached an LLM, and just to make sure that everything went well, because demos are notoriously, unpredictable, kernel attached to LLM. So let's see if everything goes well. I'm just going to run that. Great. So we have a kernel. Now, we've created a kernel. We've attached an LLM to it. And let's create something called a semantic function, right? So what is a semantic function? A semantic function is essentially a prompt that you send to the LLM, and then you get a response back, right? So let's go ahead and do that, right? So again, not going to attempt to type that. I'm actually going to go back here and copy paste the prompt. So there you go. So this is the first prompt, right? Very simple. We have a parameterized prompt, right? So we say, given this input, and I'm going to pass in that input dynamically when the code is running, summarize the above content in 5 bullet points, right? So that is my prompt. Then I'm going to create a function, right? So I'm going to call it bullet point function, and here I'm going to import, right? So I'm going to create a semantic function, right? And the prompt template is basically what prompt you want this function to run. And since we've defined that, I'm going to call that escape prompt, right? And all the rest of the stuff, because there's a lot of typing involved, I'm just going to copy paste this and talk you through it. These are the other things that go into building a semantic function. There we go. All right. So you've defined the prompt template. You give it a description. This function summarizes the input text into 5 bullet points. And then you have max tokens, temperature, top P. Won't get into details about it here, but essentially this controls the behavior of your function, right? So max tokens is the number of tokens that you don't want to go beyond that 200 tokens of text, which includes your prompt and your response. Temperature is just how creative your language model gets. So you can it's a number from 0 to 1. We don't want it to get too creative, so I mentioned at 0.1. Top P is again. It is just a number of different recall parameters that you can control with it. Again, not important for the purposes of this demo. Definitely look through the docs. But now we've created a semantic function, right, where we've defined a prompt. We've given it a description. This description is very important, and we'll come to that when we talk about planners. Now let's go ahead and run this semantic function, right? So I'm going to call it bullet point summary. So a lot of these things run asynchronously, which is why you'll see a lot of this kernel.run async. So so you'll see a lot of these happening. But before we actually run this, let's go ahead and give it this input, right? This input to this prompt, and have this little trusty text here. So there's a little text right here. So this is a blurb about Interview Kickstart. So Interview Kickstart is a highly regarded technical interview preparation platform, and this actually came out of ChatGPT. So I asked ChatGPT, tell me more about Interview Kickstart, and Interview Kickstart actually and ChatGPT actually came up with this text. So I'm going to plug this input into this prompt and get this function to run, and let's see what happens. So gonna run async. I'm going to run bullet point function with the input string as. All right, let's see what happens when we run this. Let me just clear the terminal and go ahead and run this. The kernel attached to LLM, that has happened. I forgot to print it. All right, let's do that again. Great, so what happened here, right? And let me just expand the terminal a little bit. So we created a semantic function, which is essentially a function that executes prompts. We attached a prompt to it. We gave it a description. We gave it some other parameters. And then just like you do with any function that you define, right? If you've written any code, we gave it an input, right? So this is like an argument. This particular input is like a function argument, right? So we gave it some text, which was a function argument. And then we said, go ahead and run this function, right? So this is the actual calling of the function. And this goes to the LLM, sends this text, has the LLM do its magic and bring it back. So you have this, right? So Interview Kickstart is a platform, it's summarized it into 5 bullet points, right? That's amazing, right? So we've now created a semantic function. Now, this is where it starts to get interesting for with the semantic kernel is now how do you chain this semantic function with a native function, right? A native function is what we are all used to writing if we've written any code, which is where we define functions in different classes. So for the purposes of that, I wrote this little class, right? I called it a little toy plugin. Obviously, some of these examples are a little contrived. So which is why some of this code is simple, but you can easily imagine this doing something fancier, right? You can connect to APIs or you can connect to your database and insert stuff over there. But for the purposes of this, I just wrote a little function that just replaces all the interview kickstart phrases, and we call interview kickstart IK. So it replaces all interview kickstart with IK, right? Very, very simple. But what is interesting here is how do you register this function with the semantic kernel? So for that, we have this little decorator called the SK function, right? And within this, again, you give it a description. And again, this description is important because you're telling what this function exactly does. Give it a name, and then you describe the input, right? What is the input coming into this function? Now, just a few things, and I see some questions coming to the Q&A tab. Great, keep your questions coming. I am going a little fast, but this is obviously recorded, so you're going to have it on LinkedIn Live, you're going to have it on YouTube, so you can obviously review it later. But this is giving you a sense of how this whole ecosystem works. So feel free to follow along. Some of it might be a little fast, but none of it is very complex. So you'll actually follow along pretty easily here. So just to repeat, function, decorator, that tells semantic kernel that this is a native function, give it a description, give it a name, and you have an input, right? You describe the input. So very simple native function here. So we're going to go back into where we were typing, and we're going to import this little plugin, right? So from little toy plugin, import little toy plugin. So what we're going to do here is let's register a native function, right? So I'm going to say change to IK function kernel.import skill. So this is just parlance in semantic kernel. Is they call all of these different native functions and semantic function skills. They're going to rename it into plugins, but plugin skills, they all essentially mean the same thing. They are fundamentally functions. And we did a semantic function or a semantic skill. We're now going to import a native function. And in this case, we're going to instantiate that and give it some name, right? Is change to IK. All right. So we now have a semantic function. We registered the semantic function. So we did kernel.create semantic function. We now have imported a native function. Now let's go ahead and chain these functions together, right? So chaining is very simple, the same line, right? So you have kernel.run async bullet point function, and then here I'm going to add change to IK function. And with the same input, I'm just going to call this output text. I'm going to clear the terminal, and let's go ahead and run this. All right, did a little error here, always happens in a demo. I'm going to go back to when I did this before and see what I did there. There you go. That is the mistake I did. Change to IK. Change to IK. And let me make sure that I got all of this correct. Yeah, I'll get that in there. That in there. Let's make sure that I got all of that. Let's try running this again. Awesome. So let's take a little pause and just understand what happened here. Right? So we did the semantic function that summarized it into 5 bullet points. Then we have this little toy plugin which changes all interview kickstart phrase or the words interview kickstart into IK. What happened here is the kernel ran this function first, the bullet point function first. It took that output and piped it into the change to IK function. And it used that initial input that we gave it, and it changed everything, right? So now all interview kickstart here is changed to IK. So you now have chained a semantic function to a native function and generated an output, right? So that is sort of the first piece of it, right? The first part of it. And this all builds up to what it eventually does. All right. So now that we've gone through that simple example, I'm going to close this file. Let's actually look at a slightly more complex example, right? And in this case, we don't really do this kind of stuff here, right? Generally, even when we write code, when we write functions, we actually create its own class and we put the functions in there, and then we call that function in various different places. And that's how the function becomes reusable, right? You don't generally write it inline in code like this. What semantic kernel gives you is the ability to define all your functions within a skills or a plugin directory, right? And you can bunch up all of your semantic functions. You can bunch up all of your native functions in that one place. So in this case, we have the skills directory. And here I've defined all of my semantic functions within this folder called IK skills. Now I have two skills or two plugins defined here, right? One is the bullet point plugin, which you're all familiar with. So I'm going to go ahead and open that. Now, the way to define a semantic function within the semantic kernel ecosystem is to actually use what is called an escape prompt text, right? So you create an escape prompt text file, define your input and define your prompt, right? So this is basically the prompt that's going to go to the LLM, execute and get back a result, right? And you parameterize it using this is a special parameter which semantic kernel understands that this is where I need to plug in any input that I get. Right? So that is the prompt. And the second is the actual configuration of that function, right? Which is defined within a config.json. So let me open that up. So this is a standard sort of JSON JSON format that they recognize. You give it a description. Again, I'm going to point towards this description is important. Make sure that it is well defined. Type completion. Again, we have a bunch of these different tokens that defines the behavior of the LLM. And then you define your input, right? You have your input, and what are the parameters here? This is the default parameter, which is the input, and you need to give that a description, right? And you can also give it a default value, but that input that needs to be summarized into 5 bullet points. So this part of it, once you define your prompt, you define your config JSON, you have a semantic function that can be reused in many different parts of your code. I created another semantic function, create ad campaign, and let's look at that also very quickly just for completeness. So the prompt there, again, that input there, using only the input above and nothing else, create a funny and engaging ad campaign that appeals to software engineers, right? Make sure it's G-rated, no biases, racism, bigotry, make sure it's family friendly, right? So we're just giving it very, very specific instructions, right? Create a funny ad campaign there. And same thing with the config.json, right? So you're just giving a description, take an input text and create an ad campaign text. And the input is the input that needs to be converted into an ad campaign, right? So very specific. So we know exactly what this function is doing. Now, apart from this, I also have a couple of native functions, and one of those you will recognize because we just saw it. We created a directory called change text, and within that, you need to name your file nativefunction.py. Nativefunction.py is if you're in Python, if you're in C# will be nativefunction.cs. So you open that, again, you're very familiar with this. We're changing all interview kickstart references to IK. But here, we've gone a little bit further. Right, so we obviously have this decorator called the SK function, but we also have this new thing called a context parameter, right? So a context parameter is a function, is basically a function argument, but it is what you pass in, and it doesn't have to be just one parameter. It can be multiple parameters, just like functions have multiple inputs, like multiple arguments. you can pass in multiple different context parameters. And you will see that with the other native function I have, which is the send email. Well, what this does, again, very simple function. It basically gets the ad campaign text that you get. It puts that in an email text. And obviously, if this was a real email sending function, I'd connect to a email service like Amazon SES. But essentially, this just prints out the actual email that needs to be sent. But we have multiple different parameters here, right? So you have your input, which is the text that comes out. You need a recipient name because you need to address someone. Hey, who are you? Hey, John, or hey, whatever. This is the email, and you need a recipient email, right? So you have multiple different parameters that you need to send in, and that all gets sent as part of this context variable. All right. So now we have the skills directory. We have all of our semantic skills defined here. We have all of our native functions defined here. Now, how do we go about chaining this together, right? How do we go about ensuring that all of these run together? So let's go in here. So I created this file called SK directory. You're familiar with all of this. So we've created a kernel. We've gotten all the settings, the API keys to connect to OpenAI. We add the text completion service. So this is again familiar from the previous example that we did. Now let's go ahead and import the semantic skills from this skills directory, right? So I'm going to say semantic skill sets is kernel.import semantic skill from directory, right? So I'm going to give it which directory. Now, let's print and see what this has, right? Semantic skill sets of keys. Let's go ahead and see what this has. Let me just clear the terminal. Awesome. So it has found my semantic functions, right? So it says there are two semantic functions here. One is called create ad campaign. One is called bullet point, right? So great. So that part is sorted. So we have our semantic skill sets. Now, the next thing to do is let's import our native skill sets, right? So we have change text skill. I'm going to say kernel.import native skill from directory. I'm going to give it skills, and we have this directory called change text, right? And the same thing we'll do with this send email skill. This kernel.import native skill from directory again, skills, and it's called send email. So we're going to do that same thing, just print out change text skill.keys to see what are all the skills in there. And we do the same thing with send email skill.keys just to see what's in there. And let's see what happens. Awesome. So it found that change text skill has one skill in there called change to IK. The send email skill has one skill or one function in there called send email. So we are all of this is imported now. We've imported our semantic skills. We've imported our native functions, our native skills. Now let's set up context, right? So we know we need an input, we need a recipient name, and we need a recipient email, right? So we need that context. So let's create a context, right? So I'm going to say my context is kernel.create new context. So let's create a new context, and let's feed it in all of those function arguments that we need, which I am going to copy from here. And again, we need this input. So I'm going to go there, copy this input in there, format it a little bit, get this context. So now we have the input prompt or the input text, which is interview Kickstart is a highly rated technical. This is what ChatGPT came out with. I want the recipient name is John and the recipient email is john@ik.com. So now that we've done that, let's go ahead and do this fancy chaining of all of these functions together and see what happens, right? So I'm going to say output text. And again, this all runs async. Async. So now we're going to have all the functions, right? So first, we want to do the bullet point, right? So we want to convert this into those 5 bullet points. So I'm going to first call the semantic skill sets, and we had the bullet point, right? So I'm going to call it bullet point. Then we want to take those 5 bullet points, and we want to change all interview Kickstart references to IK. So then I'm going to change text skill, and I'm going to call the change to IK function. Right? Now, once that's done, I want to then go in and create an ad campaign out of it, right? So again, we call the semantic skill sets, and we say create ad campaign. And I always misspell campaign, so I'm hoping that I got it right there. And finally, we want to send that email, right? So send email skill goes to send email, right? Now, what are we missing here? We are missing sending this context in. So we do input context is my context, right? So, all right. So let's review this function again quickly, just so that everybody understands what's happening. So what we are doing is we are chaining these functions together, right? First, we're saying create bullet points for me. Then we're saying change all references to IK, create the ad campaign, and then send the email. And this is all the context associated with it, right? And I'm going to go ahead and print this output text. I'm going to take away these little print statements I had above there. And let's go ahead and run this function. Whoa, okay, that worked. Always a good sign in a demo, but see what happened here, right? This is the final output. Hey, John, here's a GPT ad campaign since I was too lazy to do it. Are you tired of feeling like a deer in the headlights during technical interviews, blah, blah, blah. Cheers, Voodoo GPT, right? So what happened here? It took this input, sent it to the bullet point semantic skill, then took the output of that, sent it to change to IK, took the output of that, sent it to another semantic function called create ad campaign, and took the output of that and finally sent it to the send email. So the kernel is essentially giving you the ability to abstract that entire piece of it out, right? It said, don't worry about it. I got this, right? Just tell me what to run and I will run it and just give me all of the context, right? So this completely takes all of your semantic functions, all of your native functions, and gives you ways of chaining them in different interesting ways, right? So that is usually how you define your skills, how you load up your skills, and how you chain them together, right? So that is one way of sort of marrying the LLM world with your native world, right? So you have your semantic world, which is the new world that's all of your prompts and all of the things that you want an LLM to do or any generative model to do. And then you have your syntactic world, which we've all lived in so far, right? So that piece of it is all about, how, all our native functions, all the things that we've been writing and how you marry those two words. But, this is not really fun, right? We are in the LLM world. Why do I need to tell the kernel to chain these explicitly, right? So why do I need to do that? I mean, there might be use cases where you want to chain it explicitly. Imagine a world where I have hundreds of skills defined here, right? Both semantic and native. I have hundreds of these. It's going to be a pain for me to go and figure out which one of them to chain, right? So can't the kernel automatically figure out which ones to pull together? And that's where we have what is known as a planner, right? And now we'll go in and dig into planners and we'll tell you what's happening over here, right? Sorry about that. So again, a lot of the code that you're already familiar with, you have your kernel, you're instantiating, connecting the OpenAI instance of ChatGPT 3.5. You have, let me go ahead and do it in a place where we can actually type it, right? So you have all of this, you have imported your semantic skills, imported your native skills, you have your context, you have the input that we are talking about. Now let's create a planner, right? So what is a planner? A planner is essentially this this library or this abstraction that the semantic kernel gives you that uses the LLM to figure out which of your skills to run, right? How do I go about doing a job? So let's go ahead and create a planner, right? So this is the planner, and we are going to do a basic planner. And first we need to import it. So let me go ahead and import it, right? So from semantic kernel dot planning dot, and you have these different kinds of planners. So you have the action planner, basic planner, sequential planner, stepwise planner. I would recommend that you play around with this after you've seen this demo. You play around with this a little bit, but we're going to use a basic planner here. So I'm going to go ahead and import that, right? So come back here and let's instantiate that planner. And you can see that, I've been in the Java world too long and I put a new there, so you don't have to do that. So, all right, so planner, basic planner, right? Now, what do you want to do? We want to give the planner an ask. So I'm going to go in here and copy the ask. Now, what is the ask? Given the below text, let's summarize it into bullet points, change the words into Kickstart to IK, create a funny ad campaign for it, and send an email to John, whose email is john@ik.com. Right? So this is what I would like to do, right? I am in the semantic world. I am in the LLM world, right? I don't want to now explicitly chain different functions together and chain different skills together. I just want to be able to give it some text and have it figure out, right? And this is the text I want to say. It's like talking to another person. If you want to get a job done, just do this, and just tell me what works there, right? So now that we have this, let's see what happens, right? So I'm going to say plan. I'm going to say kernel dot. I'm going to say planner dot create plan async. So I want to see what plan it creates first. So I'm going to, what is the goal? The goal is the ask, and then we give it the kernel instance, right? So now I'm going to see what this generates. Right? So we want to see what, now given all the skills that we have, what is this planner doing, right? So we told, as you can see above, we told it these are all the skills you have, all the IK skills, all the change text skills, send email skills. Now that I've given you this ask, tell me what you're going to do, right? It's not going to execute it. It's just going to show me what it's going to do. So let me go ahead and run that. Whoa. What is this sorcery, right? So it has figured it out exactly the way we had chained it previously, right? So if we went back to the previous example, we explicitly said bullet point, change to IK, create ad campaign, send email. And you can see that this is figured it out exactly that way, right? It said bullet point, change to IK, create ad campaign, send email. And it has figured out, it's even gotten, sample inputs in there. It's even figured out from here that the recipient email is john@ik.com and the recipient name is John, right? So what exactly happened here, right? And how is this able to figure this out? It uses the LLM, right? It uses the LLM to actually go ahead and break this task down. And once it breaks that task down, it comes back here and matches it up against this. And this is why this description is important. Because when you're using planners and when you're using the LLM to figure out what you need to get done, this is precisely what it is using to figure out which skill associates with which task it needs to do, right? So now the piece where you've defined all of these, right? This function replaces all Kickstart references and text with IK, right? And including your input descriptions, right? The input text is the body of the email. All of these things become very critical. And if I were to imagine a world where this goes into production and you start seeing issues with the plan, the first place to start debugging is do you have the right description, right? So, and there are a bunch of debugging tools that are associated with this. I'd encourage you to sort of play around with this. But as you can see, it has figured it out exactly. It has said, we first do the bullet point, we then do the change to IK, then we do the create ad campaign, and then finally we send email. So now that this plan has been generated, let's go ahead and execute it, right? So I'm going to say output text is await planner dot execute plan, right? So now that we've created the plan, I'm going to say plan and the kernel. I'm going to comment this out so that we reduce one thing. Clear. And then I'm going to print this output text. So let's go ahead and run this. Let's see what happens. So here, while this takes a little bit of time, and I think it'll come back pretty soon, it is hitting the LLM first to figure out the plan. There you go. It's here, right? And the final thing is pretty much very similar to when we actually manually chain the functions together, right? So, hey, John, here's a GPT ad campaign. Since I was too lazy to do it, this is the ad campaign text, and here's Voodoo GPT, right? So in this, we took all of this code that we wrote, right? So all of this stuff of chaining and figuring out which skills to use, the manual chaining of it completely went out. And the planner essentially came in and this came in and executed it, right? It completely figured out which ones to use and it outputted it. Good to take a pause here. I have one more thing to cover, but good to take a little bit of a pause here and just sort of imagine what happened, right? You've taken the native world, you've taken the semantic world, and instead of writing code to then marry those two together, you're reusing the LLM. You're going back to the LLM and saying, look, I don't want to figure out and write all this code. You figure out for me what I need to do. This is my ask, and just go and figure it out and execute it for me, right? So it has completely automated that entire process, right? And you know, there are a lot of value to it. There's a lot of speed associated with it, right? So now I'm going to jump back into the presentation again. How are we doing on time? I'm a little bit behind, but I think we can catch up. So I'm going to go back here, right? So we were here. Let me go ahead and go into slideshow mode. So what have we learned so far, right? So in this part, we learned how to create a kernel and hook it up to an LLM. We created parameterized semantic functions and had the kernel executed. We created native functions and chained it with the semantic functions. And we created a planner that automatically figured out what to do given an ask, right? So we've done these 4 things. Now, the last thing I wanted to show you today, before I leave you with sort of all the goodness of semantic kernel and allow you to play with it, is vectors, right? So, and let's do a little bit of a refresher of what vectors are, right? So now we did this last week. A vector is essentially, it's an array of numbers, which is a representation of text, right? So if you have this piece of text, offers courses, there are tech professionals who transition their roles from AI ML. I wrote this little 3-line code, which is a library implementation from Hugging Face, you know, super awesome. You know, it just converts text into this vector of numbers. And then you can use this to then query for similarity, right? And this is where your semantic similarity part of it comes in. We've talked about semantic generation so far. So all of that stuff that we did about create ad campaigns and summarizing into bullet points, all of that is semantic generation. This is the similarity aspect of it, right? So you convert a sentence or text into a vector of numbers or an array of numbers. And then it is very easy in machine learning, very easy to compare 2 arrays of numbers together, right? And that'll tell you how close these 2 vectors are, right? How close these 2 pieces of or these 2 sentences are. And in this case, you know, the does interview Kickstart offer something for AI has this, it encodes into this vector of numbers. And when you do a cosine similarity, right? This is how similar these 2 sentences are. And you can use multiple other different algorithms, but cosine similarity is quite popular. You'll see that these 2 are about 78% similar, right? And the value of this is then imagine, you know, you have a large set of documents, you convert it into vectors, and then you want to do question answering with that, right? And that's a great use case because you can do searches over it, you can do question answering over it, and this helps you sort of figure out which 2 pieces of content are very similar. Now, why is this important? This is important because it enables vector databases. And again, when we talk about databases, this is a very small use case, right? This is one sentence and another sentence, but when you have millions and billions of sentences, you need a database, right? And databases essentially allow you to add semantic memories to your application, right? So what does semantic memories mean? It is what ChatGPT does today, right? You have this long conversation and ChatGPT seems to remember what you've asked it before, right? You don't have to keep re-referencing or restructuring your prompt to give it context. It knows what you were talking about. provides rich additional context to your prompt, right? So you can give it information and say, use this information to generate your stuff, right? Extends context length. We talked about it again last time. Prompts have limited context, but this allows you to extend it because you can keep iteratively adding more and more context to the prompts. And finally, since it's a database, you have indexing, sharding, fast querying, all of that good stuff here. So vector databases, one of your closest friends when you're writing generative AI apps. Let's dig back. Let's go back into the code and look at a memory example, right? So I'm going to go in here. I'll close this up. I'm going to go in here and not that file, SK memory, right? So here, what we're going to do today is put some text into a vector database and query it for some questions, right? So what is that text that I want to put in? So what I have is text about Lionel Messi, right? Pulled it from Wikipedia, just the first 3 or 4 paragraphs of Lionel Messi's life and the stuff that he's done. So I pulled that into this text. So what I'm going to do is actually going to put that into a database. And before I do that, we first need to load it up, right? So I'm going to load this up. And one of the things that semantic kernel gives you is actually some core skills, right? I mean, we have all of these skills that we define, but semantic kernel has some skills that it comes out of the box. So if I just remove this so that you can see, so it has a conversation summary skill, file IO, HTTP, which is connecting to some HTTP page, HTTPS page, GPT is not good at doing math, so it gives you the ability to do math, and there are these whole other skills, right? So these are skills that semantic kernel gives you out of the box. So in this case, we're going to use the file IO skill to actually read a file. I'm going to actually say file IO is, and we do the same thing, right? So we import skill and give file IO skill, and we give it a name, right? So read file. Now, let's go ahead and print the keys inside to see what's there, right? So again, like any skill, you can see what are the things that it has inside. I'm going to clear this, run this. All right, so it has read async and write async, right? So you can read a file, you can write a file. Great. So let's go ahead and read that file. And again, in the interest of time, I see that we're running a little behind. I'm actually going to go ahead and copy this here. So what is happening here, right? So I'm just going to rename this skill. So I'm going to read that text. So all of that stuff about Messi in this file, I'm actually going to read this in from this path, right? So I'm giving it the absolute path to this text to embed.text. So now I have text in file. Now the next thing to do is you can't stuff all of this into like one row in a vector database, right? So you have to chunk it into in either individual sentences or by some way where you need to put little pieces of it, because when you imagine a search construct, you want to be able to search over a database of a large set of vectors, right? So you don't want to stuff in that entire piece of it in one vector. So let's go ahead and chunk this. And again, I'm going to actually copy some of this code so it becomes quicker. So we're going to take that and we're going to chuck this text, right? So we're taking this text in file. We're going to use another of what semantic kernel gives us called the text chunker. We're going to split it based on some set of tokens, so 100 tokens here. So we're going to split that. And just so that we see what those chunks look like, I'm going to print the number of chunks it actually created. And I'm going to print the first chunk, all right? So let's go ahead and see what happens there. All right, so it converted that piece of text into 33 different chunks. And the first chunk in there is this, right? Lionel Messi, also known as Leo Messi, is an Argentine footballer. So that it took that first sentence and created the chunk out, right? So now, now that we've created this chunk, we first need to encode it, right? So if you go back to that presentation, we first need to encode it into this vector of numbers. Now we can do this with the way I've done it here, which is using something that Hugging Face gives you. But since we are doing OpenAI, OpenAI has its own embedding service, right? And I'm actually going to go ahead and add that embedding service here. Right? So let's go in here, add that embedding service. So what's happening over here, right? So kernel.add text embedding generation service, OpenAI text embedding, and OpenAI has this model called the text embedding ADA 002, which actually computes vectors of text that you send into it. And again, you do your API key and org ID. Now let's add the memory store, right? This is where you plug in your vector database, right? So here we go ahead and do memory store, right? So we're going to declare a memory store. And I'm going to use an in-memory vector DB, right? And semantic kernel calls it volatile memory store. But if you were to use other kernel.connectors.memory. So if you want to use actual databases, right? So you have access to all of these. You have Azure Cognitive Search, Chroma, Milvus, Pinecone, Postgres. You have all of these different vector databases that you can use and plug it in. Obviously, if it's hosted, you need an API key and send that API key to semantic kernel, but it'll figure out how to connect to these different databases, right? So, but you have all of these, but just for the purpose of this demo, I'm using an in-memory store, in-memory vector DB. So I'm going to call it memory store is volatile memory store. And let's register the memory store, right? All right, so now we have a memory store. We've created a vector DB in memory vector DB. We've registered that memory store with the kernel. Now let's populate that with the vectors, right? So we have our text embedded generation service. We have our memory store. Let's go ahead and populate it. Again, in the interest of time, I am going to go ahead and copy paste that in here. Right. So what are we doing? We took all of these chunks, we're iterating over that chunk, and we are saving that information here. Right. So we're creating a new collection or a new table inside the vector database called Lionel Messi. We are taking each chunk and calculating the vector for it, and we are pushing it into the vector DB, and we're giving it an ID. Right. So we're just calling it chunk and the index there. Right. So now that's done. Let's go ahead and query this, right? So we have all of this information about Messi. Let's go ahead and do that, right? Let's go ahead and query this. So what is happening here? We search the memory, async, obviously. We give it the collection name, and we ask a question, right? When was Messi born? And this limit is send me only 2 results back, right? So it's like a search, right? So it's going in and saying, send me 2 results back. So I'm going to go ahead and do that. And then let's look at the results, right? So I'm going to actually go ahead and copy paste that, put that in there. Let's see what happens here. So let's go ahead and run this. So this takes a little bit of time because what happens, it takes all of this, it is chunking it, all of that is fast, but it is now hitting the OpenAI API and sending each chunk for it to get converted into a vector, right? So that process happens, and then it gets sent back, and then you have it saved in the memory. So which is why that is the lag there. If you were to do this in a production environment, you would do this only once, right? You would just create the embeddings once, preferably offline, and then store that into your vector DB, and when you're live, you'll actually have it served up real time. So what is the result here? This is great. When was Messi born? It has actually taken a piece of text from what we've actually embedded. Messi was born on 24 June 1987 in Rosario. The relevance score is 90%, right? And then there is something else which is 88%. But think about this. You've not created your own in-memory search, right? So you've given it a piece of text. You've gotten a query. Imagine this is a query from the user, right? So you've created this app. User says, okay, when was Lionel Messi born? Your LLM might not know about Lionel Messi. I mean, it could be your internal process document. It could not be a document about Messi. It could be your internal process document. It could be your project documentation, and you want to create a search over it. Yeah, someone asks a question. This goes into your vector database, gets all of the information relevant to your query. And from here, you can easily chain it or send it as an input to all the stuff that we talked about, right? You can send it to a semantic function to summarize, right? You can send it to a native function to do other things, right? And this is where the vector database starts becoming very, very powerful, because it gives you that ability to move stuff to give it context and enable a use case which is called RAG, or retrieval augmented generation, right? So awesome. We are 5 minutes over, so I'm actually going to quickly stop and let's get back into code and finally revisit what have we learned so far. Right. So we did the first 4 things before. The fifth thing that you know now is you've created a semantically searchable in-memory store to enable retrieval augmented generation, right? So you've done all of this good stuff with semantic kernel, and you have to admit with not many lines of code, right? So we did that fairly quickly in the space of a 1-hour presentation. Let's quickly look at some considerations before I start taking questions, right? LLMs are awesome. They are. I mean, imagine it's much cheaper now to build these very complex apps than it used to be before, when you had to have these large machine learning models and this whole deployment architecture and this whole MLOps piece of it. All of it it's much cheaper than when you had to do it before, but it can get expensive based on the number of tokens you actually send in, right? So LLMs are being used to run semantic functions. It is being used to figure out your plans. You could potentially use it to generate embeddings. Each token starts to get a little expensive. So keep a watch on the kind of tokens and the number of times you actually leverage the LLM there. Like I said, vector databases are your friends. So a little homework for all of you. Figure out how to do semantic caching. Everybody, I'm assuming, knows what caching is. It's a key value store. But how would you do semantic caching, right? So figure that out. That's your homework. Make sure your native and semantic functions have clear descriptions, right? Because if you're leveraging the AutoMagic planner, it uses your descriptions to figure out whether it's a relevant one to use for your task. Consider predefined plans. So you don't have to generate your plan on the fly, right? You can generate it once, you can cache it, or you can create an XML for it and get SK to read it. Figure out how to do it. That's your homework, right? And finally, dig deep into the SK library. They got a lot more goodness than I could show, right? We had a short time. I had to go fast, but dig in deep. This recording is available, so you can come back and review this recording on LinkedIn, on YouTube, right? So covered in future sessions. Next week, we're going to put all of this information and actually do a we're going to solve a real problem. So come back next week. Make sure you play with semantic kernel during that time. Come back next week and we'll do that together. Other sessions in the future, we're going to do fine tuning. We're going to play around with Jupyter and Collab, logging and telemetry. And obviously, we're going to incorporate Hugging Face. It's difficult to talk about generative AI and ML in general without talking about Hugging Face. So we're going to talk about that at some point in a future session. And something that you can do over the next week, now that you've gotten exposure to SK, create an app that can take in customer reviews, classify the sentiment, and email a summary to you. Read Wikipedia articles, create a question answering app, or you can write some API to connect to Slack, get all the messages for last week, and generate a list of action items, right? So some interesting ideas for you to play with when you're thinking about semantic kernel. And with that, let's go to the Q&A. I can see that the Q&A tab was buzzing. Let me go ahead and start taking some questions. All right. So lots of questions. I'm actually going to take this. All right. So this comes. I'm doing it chronologically. So a lot of people have asked me questions very early in the presentation. So I'm going to start from there. Hi, I could have called the OpenAI APIs directly with that prompt. Why did you write a function in the kernel? Is it just for utility abstraction? That is correct, Vikash. And in case you didn't join, we are actually calling it abstraction library, right? Connecting to the OpenAI APIs, sending it the prompt, getting that response back, ensuring that entire piece of it works correctly is a lot of lines of code, right? And I've done it. So these abstraction libraries are a godsend. And they don't just give you that, they give you a lot more than just that, right? I mean, the chaining, the planning, all of that becomes very, very powerful. Right, so that is why we use the abstraction library. Ibradamir asks, would it be a case that plugins change the meaning of the context so that bullet point semantic have different bullet points. So what I'm assuming your question is if we plug in, if we send different inputs into that function, will it give different outputs, right? And that is exactly why we parameterize the prompts. Is when you send in, so the whole reason why you parameterize semantic functions is the same reason why you parameterize your native function, right? So you build a function, you have arguments, those arguments control the output, right? So you send in a different text, you send in different numbers, it gives you different outputs. The exact same thing. The structure of the prompt is the same, but you parameterize the input so that you send in different pieces of text, it will send you different outputs back depending on what you send in there. Somebody is asking about the session being recorded. Yes, this is going to be on LinkedIn Live and YouTube. So for sure, you're going to actually have access. You can review this recording, especially if you're going to be playing around with SK. All right, I'm just going over the questions that I haven't answered. Okay, this is a good question. So, how is the chaining order important, and what aspect is important? Performance, latency, or relevance? Right? Great question. So the chaining order is important in the context of the task that you want to get done. Right? So for example, in our case, we wanted to be very explicit about what needed to be done, right? We wanted to generate the bullet points. We wanted to change all interview Kickstart references to IK. We wanted to generate an ad campaign and then send an email, right? So we wanted that chaining to be important because the input of one is the output of one function is necessary as the input of the next. So in that sense, the chaining order was important. But the critical aspect, obviously, you mentioned which aspect is important: performance, latency, or relevance. When you want a program to function well and function according to the way you expect it to function, then I suppose that's what you mean by relevance. I think relevance is important, right? So just the predictability of the function or the program performing well, that is the number one thing. It has to work, right? One. The second thing obviously comes in is the rest of the stuff. Is depending on the app you build, how important is performance to you and how important is latency to you, right? So performance is important if you're having a user wait for some kind of response to come back, right? So you want it to be fast, right? And latency, I suppose, is in the same bucket, but in this case, latency also means all the time it takes to go to an LLM, have the LLM do its magic, bring you that response back, and then you doing other stuff with it, right? So I would say optimize for relevance first, right? Make sure that it works. Then think about performance and latency, and which is why the homework that I gave you, I realized I wasn't sharing my screen. So I'm actually going to share my screen when I was talking about the last pieces, right? So let me go ahead and share my screen again. Right, so I've got this slide up there, right? So if you're worried about latency and performance, make sure you leverage vector databases, because that's where your semantic caching is going to be really, really good, right? So if you have a well-implemented semantic cache, you're actually going to see that your performance is really fast, right? So, and if you have predefined plans, another way to make sure that your relevance is high, or your program is functioning as you expect it to, is consider predefined plans instead of going to an LLM and having it figure out the plan every single time. Define your plans, put it in an XML, and have SK read it. And again, this is very similar, right? You have an XML with a description, very easy to have semantic kernel actually pick up the right plan based on the ask that you have. So the next question is, are semantic skill sets and the native functions running locally or actually sent to the LLM running on OpenAI servers? Semantic goes to LLMs because it's a prompt, and you're sending the prompt along with the information to the LLM, right? So semantic runs on the LLM. Native functions are running locally because they are native functions, right? So they are running locally within your server, within your app environment, right? So that is the difference. You have all of us have all lived in the native functions world, right? Before this whole explosion of ChatGPT and LLMs came about, we all lived in the native functions world, unless you were obviously in the deep learning and the machine learning world. We've all lived in the native functions world. We are used to writing functions, be deterministic, and be very precise with our syntax, right? In Java, if you don't put a semicolon, the code doesn't compile. this essentially marries those two worlds together. Now these two worlds intersect. Semantic world and your native world intersect. So your semantic world runs on an LLM, your native world runs locally on your server environment. And that's how the magic actually happens with these generative AI apps there. All right. More interesting questions. Can a planner fall into a circular state when it cannot get out? Yes, it can. It absolutely can, which is why it is always a good idea to have it generate its plan, right? Imagine a world where you have hundreds, potentially thousands of skills within that skills folder, right? Here, this is fairly simple. We just have a few skills over here, right? So we just have three things here, very easy for the planner to figure out. The planner is actually great. I mean, there are some examples on the semantic kernel website that Microsoft has put out where you have hundreds of skills and it is able to go in and figure out which skill to use. In a world where you can have a lot of out of the box plugins, right? Because eventually the world is going to be where you're going to not only build your own skills or plugins, you're going to have out of the box plugins that other people put out there that you import into your project, right? So in that world, you are going to have cases where if you're using the planner which is hitting the LLM to figure it out, it can go into a circular state, right? So which is why generating plans and first auditing that plan before it actually executes is important. In a production state, I would imagine that it's very unlikely that you would do like a real-time plan where you tell the LLM to figure it out. You would do a lot of these as part of your testing and just making sure that you can chain functions in ways that you hadn't thought about, right? So those are interesting ways of using the planner there. All right, I think there are more questions about the planner, but I'm going to encourage all of you to go figure it out. I'm going to take a few more questions because we are about 15 minutes over time. All right, Jagdish asks, is it correct to say the ask provided to the planner uses keywords, bullet points, change text, and send email? It actually deciphers them as prompts. Will they work equally well if we substitute them with their synonyms? If no, can figuring out synonyms to the keywords also be one of the skills, right? So fantastic question. So the ask that is provided to the planner actually uses those descriptions, right? So and actually uses those keywords and to figure out how to enable the right plugins to use, right? So if we go back to the code, let me actually go back to the escape panel code. It'll be easier to explain there. So what does it do? And in some ways, I would encourage you to go into some of these libraries and look at the code, right? I mean, since you asked this question, Jagdish, I would highly recommend. I mean, I've done quite a bit of this as I was preparing for this demo, right? I actually dig into each of these and figure out what it's actually doing. What it does is it actually sends this to the LLM and basically says, break this down into steps, right? What is this ask telling me, right? So it's like sending the same thing to ChatGPT and saying, okay, just break this down into as many steps as you can in terms of what I should be doing. So ChatGPT is very good at that, right? It says, okay, given this text, it says that, okay, first you need to summarize bullet points, then you need to change words, then you need to do this, then you need to send an email, right? So it gives you that list of things back. So it is hitting the LLM for that. And now once it comes back, what semantic kernel is doing is essentially what we did with the memory part of it, right? It is embedding these different points that it needs to do and comparing it to the descriptions, right? So it is comparing it to these descriptions and saying, is this the right skill to use? And it is going iteratively through each of the skills that are there defined within your skills directory and saying which is the right tool or which is the right plugin to use, right? So it is doing that vector comparison against this description. It is doing a vector comparison against the description of the parameters, and then deciding based on probability. The first thing to do is to use the bullet point skill because it is a 95% probability that this is the one that is associated with this first step in the planner, right? So that is the way the planner figures it out, right? So it uses the LLM to break down the ask and then uses the individual pieces of that ask to then compare it to the descriptions that you have and figure out which is the right one to use. So that is really the way the planner sort of figures it out. So when you say, can we substitute them with their synonyms? Not quite sure what you mean, but since the first step is going to the LLM, it is fundamentally, you can put synonyms in there and it'll still be able to understand. You don't need to create a separate skill to figure out synonyms of words. But again, I haven't come across a use case. When you play around with it, you might come across this use case yourself, right? The second question that you're asking is, will the planner ability be volatile between the LLM models? If so, how is testability warranted for plan generation? I'm seeing that it closely follows the SQL plan generation. Absolutely, that's a great insight. It follows the SQL plan generation, where once in a blue moon we would have to inspect to correct in case of a bad actor. Absolutely right, right? So, which is why always a good idea to generate your plans and review it. One of the things that I would encourage all of you to do is actually go to the semantic kernel website where Microsoft has hosted it. There is something called a chat copilot, right? And this is something that they have built on top of semantic kernel. They have this section called planners. And by the way, the semantic kernel extension also has something where you can test plans, right? So you can create a plan and you can test plans, right? So you can actually go in and use a semantic kernel extension on VS Code to create a plan and test it. But there is volatility there because since that planners, if they're using the LLMs, are fundamentally probabilistic, you're going to have to debug it. You're going to have to test it. And you're going to have to make sure that you create some level of deterministic predictability into that process, right? So which is why the recommendation is unless you have like use cases which are fundamentally controlled, like this one, right, where you have 3 skills here or 4 skills here that the planner needs to decide between. Make sure that you actually have predefined plans, and that will give you a lot more predictability in that process. All right, I'm going to take one more question. We're way over time, but such amazing questions here. I'm going to take one more and then we'll close it there. How will we manage hallucinations? I'm surprised nobody asked this question, right? In a retrieval augmented generation context, right? How do we manage hallucinations? Let me go back to the here, right? Vector databases are your friends, right? To prevent hallucinations. When we talk about retrieval augmented generation, right? You want to make sure you want to reduce context of what the LLM is doing, right? And that's when LLMs are probabilistic. You don't know what's going to come out of them, right? So how do you control them in a way, right? 2 things. You give it context, and that's where vector databases are your friends, right? So you go and you tell the prompt, don't use anything else. Don't use your own memory. I'm giving you an open textbook, right? Read this and generate your answer out of this, right? So vector databases are your friends. And prompts are your friends, right? Make sure you structure your prompts in a way where you enable it to only stick to a defined context, right? So that is sort of the second thing that you have to make sure. So remember, vector databases, best friends in almost any generative AI app building context, but especially when it comes to hallucinations. All right, folks, I am going to stop here. I apologize. There are many more questions here that I would have loved to answer, but in the interest of time, I'll pause here. Thank you all so much for joining this. I had a lot of fun. In case you guys didn't already realize that, I had a lot of fun doing this. I appreciate it. I appreciate all the time that you have put in sort of figuring this out. Make sure you attend next week's session, because that's when we're going to put all of this together and solve a real world problem. So thank you all so much for spending time with me today, and have a good evening. I'll see you all next week.